Hello to the HubLE audience. My name is Jonathan Gustafson. I am a postdoc research fellow at Rush University Medical Center in Chicago, Illinois, and I am also a co-chair of the HubLE Meet the First Author Committee, as well as a member of the meeting reports at the ORS. And today we're having a novel session of the ORS meeting reports. I'm joined today by Vikas Manjunath at the UIC, University of Illinois, Chicago, Rockford location as a second-year medical student. Vikas, thanks for joining us today. How are you doing?
I'm doing well. Thanks for having me.
Absolutely. We're going to talk today about your podium presentation at the ORS 2020 in Phoenix. The title of your talk was Vitamin E Alters the Effects of Cobalt, Chromium, Molybdenum, Degradation Products on DNA Replication Fork Initiation and Progression. So this was your first ORS conference. Congrats again on having a nice podium talk at the conference. Can you tell us a little bit about the big picture of your work?
Totally. So I work in a lab that is studying tribocorrosion. So we're looking at the effects when we have orthopedic implants in patients and the degradation that happens of those implants over time. One of the fields that we're studying is the toxicity effects of those products that get shaved off from these implants. And that's primarily where my research lies. So we were looking at, for this particular type of implant with this cobalt, chromium, molybdenum alloy, we were looking at what are some of the toxic effects that happens as these metal particles get shaved off. And specifically, we were looking at cytotoxicity, so cell death, but we were also looking at genotoxicity, the effects to the actual DNA. And in doing so, we were using a somewhat novel technique called DNA fiber analysis that was actually optimized by a professor that's working at our campus.
That's excellent. So what were kind of some of the key findings from your work relating to the degradation products, as well as both the DNA and cytotoxicity that you were talking about?
So we were looking to see if the use of vitamin E could actually prevent some of these toxicity effects. So on the first half, looking at the cytotoxicity, we saw that these metal particles caused a lot of cell death, but with the presence of vitamin E, that was actually prevented at pretty much all concentrations. So that was pretty striking. And then on the DNA side, if you don't mind, I'm just going to share real quick to show you a table of some of our findings.
So again, you're interested in the vitamin E effects, right? Okay, so right. I see your table here.
Right, so we found that actually when we applied these metal particles, we saw a couple of effects. We were able to see a slowing down of the replication speed in the presence of these degradation products, as we have listed here. But when we include the vitamin E as well, we actually see that the replication is not slowed down. In addition, we see a change in some replication dynamics in terms of what are some of these replication intermediates that we were able to find. It's a little more technical, but we were able to find that when you add degradation products, it altered these replication dynamics. But when you also add vitamin E, it prevents this change. And these changes were in line with hydrogen peroxide, which is a known kind of positive control that's supposed to induce some of this oxidative stress that we expect the degradation products are causing.
That's really interesting and very exciting. There's been a lot of work, certainly, and this is actually a really interesting hot topic in the field of orthopedic implants. How can we, as researchers, as well as material scientists, introduce these different types of compounds and components to our implants to be able to do a better job of integrating with the patient, but also obviously maintaining the longevity of the implant, right?
Mm-hmm. Actually, so one of the other, sorry, yeah.
All right, go ahead.
One of the other projects that I'm currently trying to submit to a journal is looking at vitamin E's effects, studying a slightly different cell line, but we're also trying to take a look at the corrosion inhibition effects that vitamin E has itself. So not only does it prevent some of these toxicity effects in the periprosthetic tissues, but it actually has been demonstrated that it also prevents some of the corrosion of the implant itself. So on both fronts, it appears that vitamin E actually shows a lot of promise in use in orthopedic patients.
That's excellent. Wow. So it sounds like you've made some really great strides, especially this being your first conference presentation. And it sounds like your lab group is on to some really interesting and exciting work. So can you tell us a little bit about the next phase or step in your career and how this podium presentation and this work helps with that?
Sure. I'm currently a second-year medical student. So right on my horizon is my first board exam. So that's currently what's, my focus. But after those board exams are done, I'm hoping to write up this project into a paper So hopefully you can join the other paper that we currently have coming out. And in the long run, I'm hoping the reason I joined this lab in the first place is that I had some interest in going into orthopedics. And if that continues to end up being the case, then hopefully someday I can actually have a part in trying to translate this research into actual use of vitamin E in patients to try and improve the longevity and outcomes for patients with implants.
That's excellent. Well, it's really great to hear from you. We really appreciate having you. You are definitely in the infancy of your research career as well as your clinical career. We wish you the best of luck for sure as you kind of go through and continue through your education. And we look forward to hearing more from your group, and we will keep an eye out for your papers.